The skies shimmer in shades of burnt orange, dense clouds swirl with corrosive droplets of sulfuric acid, and the surface below sears at nearly 900 degrees Fahrenheit, hostile and unyielding, a true vision of planetary hell. Yet, high above this uninhabitable surface, imagine a realm where humanity could thrive, surrounded by cutting-edge technology, suspended in cities that float like islands in an alien sea. This isn't the plot of a distant science fiction epic. It's an audacious scientific proposal to colonize Venus, Earth's enigmatic twin. How could we possibly conquer such an extreme environment? What would it take to transform this vision into a reality? Today, we'll explore the stunning science, revolutionary engineering, and sheer ambition behind the concept of floating cities on Venus. Let's uncover how humanity might one day call the skies of Venus our home. Venus, with its scorching surface and toxic atmosphere, might seem like the last place humanity would consider for colonization. But when you look beyond the planet's hostile reputation, it's clear why many scientists are captivated by its potential. Often referred to as Earth's twin, Venus shares striking similarities with our home planet. It's almost the same size, just slightly smaller, and its gravity is about 90% that of Earth's, meaning humans could walk and function there without the long-term health risks posed by lower gravity environments. This alone gives Venus a significant edge over other potential destinations like the Moon or Mars, where gravity is far weaker and could cause complications over time. The real game changer, however, lies not on Venus's surface but high above it in its thick, suffocating atmosphere. At an altitude of around 31 miles, the conditions are shockingly Earth-like. The temperature here hovers around 70 degrees Fahrenheit, and the atmospheric pressure is nearly identical to what we experience at sea level on Earth. In fact, this region of Venus's atmosphere is often described as the most Earth-like environment in the entire solar system. While we would still need to contend with acidic clouds and a lack of breathable air, these challenges pale in comparison to the brutal conditions on the planet's surface or even on Mars, where temperatures often plunge to far below freezing and oxygen is almost non-existent. And let's talk about that thick Venusian atmosphere. While it might be deadly to breathe, it offers something that Mars cannot: natural protection from space radiation. Venus's dense atmosphere acts like a shield, blocking harmful cosmic rays and solar radiation that could pose serious risks to human health, equipment, and infrastructure. On Mars, which has a much thinner atmosphere and no magnetic field, colonists would need to burrow underground or rely on heavy radiation-proof materials just to stay safe. On Venus, floating habitats in the upper atmosphere could take advantage of this natural barrier, reducing the engineering challenges and risks significantly. But why Venus and not Mars, a planet that's been the poster child for colonization for decades? Much of Mars's appeal lies in its surface. The idea of one day walking on Martian soil holds a certain romantic charm. Yet from a purely practical standpoint, Venus offers some unique advantages. For starters, it's much closer to Earth. A mission to Venus would take just a few months compared to the nearly year-long journey required to reach Mars. This proximity reduces costs, travel time, and the psychological toll on astronauts. And unlike Mars, where colonists would be exposed to extreme cold and a thin atmosphere that barely supports basic life support systems, the conditions in Venus's upper atmosphere, where floating cities would be located, are much more stable, predictable, and Earth-like. There's also energy to consider. Venus enjoys 2 times more sunlight than Earth, making it an ideal place to harvest solar power. This abundance of sunlight could fuel floating habitats, creating a sustainable energy source for life support systems, research labs, and more. On Mars, the weaker sunlight and frequent dust storms mean solar power is far less reliable, forcing engineers to rely on nuclear alternatives which come with their own challenges. Of course, this isn't to say Venus would be an easy destination. Challenges like the corrosive sulfuric acid in its clouds would require innovative materials and technology to overcome. But when you weigh the pros and cons, Venus challenges many of our preconceptions about what makes a planet viable for colonization. From its Earth-like conditions high in the atmosphere to its abundant solar energy and radiation protection, Venus offers a tantalizing alternative to Mars. So, while the idea of floating cities on Venus may sound far-fetched, science suggests that Earth's fiery twin might just be one of our most realistic options for life beyond our home planet. Picture this, a futuristic city shimmering under the soft golden glow of reflected sunlight, suspended high above the suffocating chaos of Venus's surface. Entire communities thriving in the skies, floating peacefully like helium balloons in a realm where the air pressure and temperature are oddly familiar. It sounds like a scene from science fiction, but the science behind these so-called floating cities is grounded in the laws of physics and some ingenious engineering. So how would such cities actually work? The concept hinges on a simple yet powerful principle: buoyancy. Just as helium balloons rise in Earth's atmosphere because helium is lighter than the air around it, floating cities on Venus would rely on aerostats, massive, balloon-like structures filled with breathable air. Here's the fascinating part. On Venus, the breathable air humans need, a mix of nitrogen and oxygen, happens to be much lighter than Venus's dense carbon dioxide atmosphere. This means that an enclosed structure filled with breathable air would naturally float, in the same way a balloon rises when filled with a gas less dense than the surrounding air. By utilizing this principle, aerostats could effortlessly remain suspended about 31 miles or 50 kilometers above the planet's surface, within the layer of Venus's atmosphere where temperatures are similar to a pleasant day on Earth. These aerostats wouldn't simply be balloons, of course. They'd be massive, meticulously engineered structures designed to house entire cities. Imagine colossal domes, built using ultra-lightweight yet incredibly strong materials like advanced polymers and carbon fiber composites. These materials would need to withstand not only the pressure differences between the internal habitat and the outside atmosphere, but also the highly corrosive sulfuric acid clouds that envelop Venus. To combat the acidity, engineers propose coatings or layers of acid-resistant materials, ensuring the structures could endure the harsh conditions without weakening over time. Inside these floating cities, life could look surprisingly normal. The pressurized habitats would maintain Earth-like conditions with temperature, humidity, and oxygen levels carefully regulated to mimic those of our planet. Solar power, abundant in Venus's skies due to the planet's proximity to the Sun, could provide a nearly endless energy source. With twice the solar energy available compared to Earth, these cities could harness sunlight through advanced photovoltaic panels, powering everything from air filtration systems to artificial gravity devices, and even lighting to simulate the day-night cycle. But what about stability? Wouldn't floating cities drift aimlessly or be vulnerable to Venus's high winds? This is where modern engineering truly shines. By incorporating propulsion systems powered by the very sunlight Venus provides, these aerostats could adjust their position and maintain stability. Venus's winds at this altitude blow consistently, but they're not turbulent. This means the floating habitats could either ride the currents or remain stationary with minimal energy expenditure, much like hot air balloons tethered to a specific location. Another marvel of these cities would be their self-sustaining design. Engineers envision closed-loop systems where water, air, and nutrients are continuously recycled, minimizing dependence on resupply missions from Earth. Water could be harvested directly from Venus's atmosphere, as it contains trace amounts of water vapor. The sulfuric acid in the clouds could even be processed to extract oxygen, while waste products from human activity could be converted into useful materials or energy. These systems would operate in harmony, creating a sustainable environment where humans could live and work for extended periods. The science behind floating cities on Venus is a testament to humanity's ability to adapt and innovate, even in the face of extreme challenges. By reimagining what's possible with proven physical principles like buoyancy, harnessing cutting-edge materials, and utilizing Venus's unique resources, these cities could transform one of the most hostile worlds in the solar system into a thriving hub of human activity. It's not just a dream, it's a vision of the future grounded in bold ideas and scientific ingenuity. While the idea of floating cities in Venus's upper atmosphere paints an inspiring picture of humanity's potential, life in this alien environment would be anything but easy. Venus may offer Earth-like conditions in a narrow slice of its atmosphere, but it's still a profoundly hostile world. From corrosive sulfuric acid clouds to unpredictable atmospheric winds, the challenges of living in Venus's skies push the limits of engineering and human resilience. So, how could we overcome these hurdles and create thriving, self-sufficient habitats in such a volatile environment? Let's start with one of Venus's most infamous features, its thick atmosphere laced with sulfuric acid. At the altitudes where floating cities would exist, the clouds are dense with droplets of this highly corrosive substance, posing a constant threat to the structural integrity of habitats and equipment. To address this, scientists are already exploring advanced materials capable of resisting such extreme chemical attacks. For example, specialized coatings made from fluoropolymers like Teflon or innovative acid-resistant ceramics could be used to protect the outer surfaces of floating cities. These materials are not just theoretical, they're already used on Earth in industries handling highly reactive chemicals, from manufacturing plants to laboratory environments. Adapting and enhancing these materials for the Venusian atmosphere would be a critical step toward making floating cities viable. In addition to protective coatings, redundancy will be key. Engineers could design modular systems for these habitats, allowing damaged sections to be quickly repaired or replaced without compromising the entire structure. For example, external panels could be swapped out by robotic drones, reducing the need for risky human spacewalks in such an unforgiving environment. Moving on from corrosion, let's talk about the winds. At the targeted altitude for floating cities, Venus experiences powerful hurricane-force winds averaging up to 200 miles per hour. While these winds are consistent and predictable, they pose a challenge for stability and navigation. The good news is that modern aerospace technology provides a roadmap for dealing with such conditions. Propulsion systems powered by solar energy could keep floating habitats stationary or allow them to drift with the wind if desired. These systems would use lightweight, efficient electric thrusters to make subtle adjustments to position without consuming large amounts of energy. And while the winds are strong, they're not inherently chaotic. Venus's atmosphere at these altitudes behaves more like a steady jet stream than the violent storms we see on Earth. By designing habitats to move with these currents, engineers could reduce the structural stress caused by resisting the wind, much like how airplanes adjust their flight paths to flow with prevailing winds rather than fight against them. But the challenges don't stop with the external environment. Creating a sustainable living system for human life in the Venusian atmosphere requires innovative solutions. A major focus would be the development of closed-loop ecosystems, where every resource, air, water, and food is continuously recycled. For example, water could be extracted from the atmosphere itself. Venus's clouds contain trace amounts of water vapor, which could be captured through specialized condensation systems. This collected water would then be purified and recycled endlessly, supporting both hydration needs and agriculture within the floating cities. Air would also need to be carefully managed. While Venus's atmosphere is dominated by carbon dioxide, this could actually be an advantage. Using advanced technologies like the ones already employed on the International Space Station, carbon dioxide can be split into oxygen for breathing and carbon, which could be repurposed for materials or energy storage. This means that the air inside the habitats wouldn't rely on continuous resupply missions from Earth, making the floating cities more self-reliant. Food production is another hurdle, but innovations in vertical farming and synthetic biology could play a significant role here. Hydroponic systems, which grow plants without soil, could thrive in the controlled environment of the habitat, providing fresh produce for the inhabitants. Meanwhile, lab-grown proteins could supplement diets, dramatically reducing the need for conventional farming methods that would be impractical in such a setting. Finally, power generation would be a cornerstone of sustainability. With Venus receiving about twice as much sunlight as Earth, solar energy would be an abundant and renewable resource. Entire sections of the floating cities could be equipped with advanced photovoltaic panels, designed to convert sunlight into electricity with incredible efficiency. This energy could power everything from life support systems to propulsion and even large-scale manufacturing inside the habitats. The challenges of living above Venus are immense, but they are not insurmountable. By combining advanced materials, adaptive engineering, and cutting-edge sustainable technologies, humanity could one day turn the hostile skies of Venus into a new frontier for exploration and habitation. These obstacles might seem daunting, but history shows that the boundaries of human innovation are often pushed the hardest when we're faced with the greatest challenges. And perhaps floating cities in Venus's atmosphere will become proof of just how far we're willing to go to turn the impossible into reality. To survive and thrive in the skies above Venus, self-sufficiency isn't just a luxury, it's a necessity. Floating cities would have to operate like closed-loop systems, relying on sustainable methods to generate energy, grow food, and produce water without regular resupply from Earth. These challenges might seem overwhelming at first, but with clever engineering and advanced technologies, we could build habitats capable of supporting human life indefinitely. So, how would such a system work in such a dramatically different world? Let's begin with energy. Venus offers a unique advantage when it comes to power generation: sunlight. Venus is closer to the sun than Earth, and with its thick clouds reflecting light, there's an abundance of solar energy available. In fact, the upper atmosphere of Venus receives more sunlight than almost anywhere else in the solar system, even more than Earth or Mars. Floating cities could be equipped with advanced solar panels designed to capture and convert this energy efficiently. Modern photovoltaic technology, such as flexible and lightweight solar films, could cover large sections of the habitats, ensuring a consistent and renewable energy supply. The power generated could then fuel life support systems, water recycling processes, and even farming operations. And unlike on Mars, where frequent dust storms can block out sunlight, Venus's skies would offer a continuous and predictable energy source, a massive advantage for long-term habitation. But energy is just one piece of the puzzle. Food production would also need to be addressed, and this is where vertical farming and hydroponic systems come into play. Instead of relying on traditional soil-based farming, hydroponics allows plants to grow in nutrient-rich solutions, using minimal water and space, both of which are at a premium in a floating city. Entire levels of these habitats could be dedicated to vertical farming, where plants are stacked in layers under artificial light powered by solar energy. Crops like leafy greens, tomatoes, and even protein-rich options like algae or soybeans could be cultivated efficiently. These systems are already being tested on Earth in urban areas with limited space, proving that they can produce high yields using relatively few resources. But what about protein, which is typically harder to produce in controlled environments? Advances in synthetic biology could lend a hand here. Lab-grown meat, a technology that's already gaining traction on Earth, could supplement the diet of Venus's inhabitants. By replicating the cellular structures of animals, scientists could produce meat without the need for livestock, using tanks and bioreactors that require far less space than traditional farming. Additionally, insects, already a popular protein source in many cultures, could be farmed in small, energy-efficient systems, providing another sustainable option for food. Together, these solutions could ensure a varied and nutritious diet for the residents of Venus's skies. And then there's the question of water, a resource that's critical for survival but incredibly scarce in most extraterrestrial environments. Fortunately, Venus's atmosphere contains trace amounts of water vapor even at high altitudes, and this could be harvested using advanced condensation systems. These systems would work by cooling the air around them to collect water droplets, much like rain forms on Earth. Once collected, the water could be purified and stored for use in drinking, farming, and other essential processes. As part of a closed-loop system, this water would be continuously recycled, with wastewater treated and converted back into clean, drinkable water. Technologies like this are already in use on the International Space Station, where astronauts rely on systems that reclaim nearly every drop of moisture, from sweat to condensation, to stay hydrated on long missions. Efficiency would be the cornerstone of these floating cities. Every resource, air, water, food, would have to be carefully managed and reused to minimize waste. For example, the carbon dioxide exhaled by humans could be captured and used to feed plants in the farming systems, while oxygen released by the plants would refresh the breathable air for the inhabitants. Waste materials could be broken down and repurposed into nutrients for crops or raw materials for 3D printing, closing the loop on resource consumption. By combining solar-powered energy systems, innovative food production methods, and water recycling technologies, Venusian floating habitats could become models of sustainability. These systems wouldn't just support survival, they'd pave the way for a thriving way of life, proving that even in the most alien environments, humanity's ingenuity knows no bounds. What's remarkable is that much of this technology already exists today. The challenge lies in scaling it up and adapting it to Venus's unique conditions. But with these sustainable solutions, the dream of floating cities in Venus's skies moves one step closer to becoming reality. To turn the vision of floating cities on Venus into a reality, humanity will need more than just bold ambition and clever engineering. We'll need to lean heavily on artificial intelligence and robotics, our indispensable allies for overcoming the planet's extreme challenges. These cutting-edge technologies will act as both our tools and co-workers, performing tasks that would be far too dangerous, complex, or tedious for humans to handle. In many ways, AI and robotics will be the backbone of any mission to colonize Venus, ensuring survival and efficiency in an environment as unforgiving as the planet's toxic skies and scorching surface. First, let's consider the role of artificial intelligence. AI would be the brain behind the operation, managing systems critical to life in floating cities. Life support systems, for example, would need constant monitoring and adjustments to maintain the delicate balance of oxygen, carbon dioxide, temperature, and humidity inside the habitats. Unlike humans, who can only react to changes after they occur, AI could predict and prevent potential failures before they happen. By analyzing streams of data from sensors embedded throughout the habitats, AI could detect anomalies, optimize energy usage, and even adjust farming operations to maximize crop yields. Essentially, it would act as the silent caretaker of these habitats, ensuring smooth operations while freeing humans to focus on exploration, research, and innovation. But AI wouldn't just stop at maintaining floating cities. It would be central to their creation. The construction of habitats, especially in Venus's unpredictable atmosphere, would require a level of precision and coordination that's nearly impossible for human teams to manage alone. AI could oversee autonomous construction systems, using advanced algorithms to deploy robotics and drones that assemble habitats piece by piece. It's not hard to imagine swarms of drones working in unison, guided by AI, to attach individual panels or repair damaged sections of a structure. These intelligent systems could adapt in real time to shifting winds or unexpected conditions, ensuring progress doesn't grind to a halt. Speaking of robotics, they would play an equally vital role both above and on Venus's surface. While humans might live in relative comfort in the floating cities, there's still immense value in exploring and harvesting resources from the planet's surface, even though it's one of the harshest environments in the solar system. With temperatures hot enough to melt lead and atmospheric pressure 90 times that of Earth, sending humans to the surface is entirely out of the question for now. This is where advanced rovers and drones come in. These machines, built to withstand the searing heat and crushing pressure, could scour Venus's surface to gather data and materials. They might map the terrain, drill into volcanic rock, or analyze chemical compositions to identify useful minerals or compounds that could be extracted and sent to the floating cities. Unlike their counterparts that explore Mars, Venusian rovers would face a unique challenge: durability. To endure the extreme conditions, they'd likely rely on heat-resistant materials like silicon carbide and advanced ceramics, as well as innovative cooling systems to keep their electronics operational. NASA recent concepts, such as the ARI rover, short for Automaton Rover for Extreme Environments, are promising examples of the kinds of robotics that could one day tread Venus's surface. Drones, on the other hand, would be invaluable in the skies. These aerial machines could zip between floating cities, carrying tools, supplies, or even conducting maintenance on the habitats. Imagine fleets of maintenance drones patching up damaged hulls or applying acid-resistant coatings to external structures, all while being guided by AI to ensure flawless execution. This would significantly reduce the need for human spacewalks, which are not only risky but also resource-intensive. Finally, there's the potential for AI and robotics to enhance resource management and sustainability. AI-powered harvesters could work in tandem with robotic systems to extract trace amounts of water vapor or process sulfuric acid in Venus's atmosphere to produce oxygen. These tasks require constant precision and optimization, something that AI excels at, ensuring nothing goes to waste and resources are used as efficiently as possible. Meanwhile, robots could assist with waste processing, turning organic material into fertilizer for crops or extracting elements for 3D printing new parts and tools directly on site. The collaboration between humans, AI, and robotics wouldn't just make survival on Venus possible, it could turn it into prosperity. By automating the most challenging or monotonous tasks, these technologies would allow humans to focus on creativity, innovation, and scientific discovery. They'd effectively extend our reach and capabilities in an otherwise unimaginable environment, proving that with the right tools, even the most extreme frontiers can become a new home for humanity. It's clear that artificial intelligence and robotics won't just support life on Venus, they'll redefine it. Beyond the dazzling technologies and daring engineering feats required to colonize Venus, there's an even bigger question we can't ignore. Should we do it at all? While the idea of floating cities on Venus is an inspiring testament to human ingenuity, it also opens the door to complex ethical and philosophical dilemmas. How do we balance our dreams of expanding beyond Earth with the responsibility to fix the problems we've created here? What does it mean to alter or occupy an alien world, and who decides if it's the right thing to do? These aren't just theoretical questions, they're the kinds of issues we need to grapple with as we push the boundaries of human exploration. One of the strongest ethical arguments against colonizing Venus or any other planet comes from the perspective of prioritization. Earth, our one irreplaceable home, is facing unprecedented environmental challenges. Climate change, biodiversity loss, and resource depletion threaten the very ecosystems that sustain us. Critics argue that the vast amounts of money, talent, and resources required to colonize Venus would be better spent reversing the damage here on Earth. After all, why explore the heavens when we're struggling to care for the planet we already inhabit? To them, pursuing Venusian colonization feels like escaping responsibility, a way to abandon Earth rather than address the root causes of its problems. On the other hand, supporters of space colonization often frame it as a necessary step for the survival of our species. As global risks like nuclear conflict, pandemics, and climate collapse grow, the idea of having a backup plan starts to make more sense. Venus or Mars or another celestial body could serve as a lifeboat for humanity in case Earth becomes uninhabitable. This perspective sees planetary colonization not as abandoning Earth but as hedging against an uncertain future. By spreading across the solar system, humanity would reduce its reliance on a single planet, increasing our chances of long-term survival. But even if we agree that expanding to other planets is a good idea in theory, what about the environmental implications of doing so? On Earth, human expansion has often led to the destruction of natural habitats and ecosystems. While Venus may not have life as we know it, our track record raises important questions about how we would treat an alien world. Should Venus, with its own unique and extreme environment, be preserved in its current state as a kind of cosmic heritage site? Or is it acceptable for humanity to reshape it for our own purposes, as we've done with so much of Earth? These are uncharted ethical territories, and they force us to reflect on our role in the universe. Some philosophers argue that humanity has a moral obligation to explore and expand. It's in our nature to seek knowledge and push boundaries. But others caution that colonizing Venus could set a dangerous precedent. By altering an alien world to suit our needs, we risk perpetuating the same patterns of exploitation that have caused so many problems on Earth. It becomes a question of balance. Can we pursue exploration and colonization in a way that respects both the places we explore and the lessons we've learned about sustainability? And then there's the issue of who gets to decide what happens on Venus. If we're serious about colonizing another planet, how do we ensure it's done equitably? Throughout history, exploration has often been driven by a few wealthy nations, corporations, or individuals, while the benefits and the consequences are distributed unevenly. Will the same dynamics play out in space? Who owns Venus, if anyone? Should it belong to all of humanity, or will it become another frontier dominated by those with the resources to claim it first? These questions highlight the need for robust international agreements and ethical frameworks to guide space exploration. Ultimately, the question of whether we should colonize Venus might not have a simple answer. It's a debate that touches on everything from survival and sustainability to responsibility and fairness. What's clear, though, is that we need to have this conversation now, before we take those first bold steps into Venus's atmosphere. Our choices will shape not just the future of humanity, but our legacy as a species. Will we be remembered as explorers, caretakers, or colonizers? That's a question only we can answer. When we think about colonizing Venus, it's easy to get overwhelmed by the sheer scale of the challenges. But as daunting as the idea may seem, we don't have to start entirely from scratch. Right here on Earth, we've already tackled some of the harshest environments imaginable, places where survival pushes the limits of human ingenuity. From underwater habitats to polar research stations, our experiences on Earth offer a treasure trove of lessons that could guide us as we plan for life in Venus's skies. Let's take a closer look at how our adaptations to extreme conditions on Earth might prepare us for Venusian colonization. First, consider life beneath the ocean. For decades, humans have been building and operating underwater habitats that allow scientists to live and work for extended periods beneath the waves. Take the Aquarius Reef Base in Florida, for example, the world's only operational underwater laboratory. This facility has taught us how to create isolated, pressurized habitats in an environment where breathable air is non-existent, temperatures fluctuate, and resources are limited. Sound familiar? Much like a floating city on Venus, the Aquarius habitat relies on life support systems that manage oxygen, remove carbon dioxide, and maintain livable pressure. It's a real-world demonstration of how technology can turn an otherwise hostile environment into a temporary home. And just as underwater habitats rely on careful resource management and recycling to make the most of their constrained supplies, Venusian cities would need closed-loop systems to conserve air, water, and nutrients. Then there's Antarctica, often described as the harshest place on Earth. This frozen continent may not have Venus's unrelenting heat, but it presents similar challenges in terms of isolation, extreme weather, and a lack of readily available resources. Research stations like McMurdo and Amundsen Scott have been operating for years in complete isolation during the brutal Antarctic winters. These facilities are essentially self-contained worlds. They're designed to withstand sub-zero temperatures, provide sustainable power, and recycle water and waste. More importantly, they've taught us how to cope with the psychological toll of extreme isolation. For researchers living months or even years in such environments, mental health is a top priority. Strategies like structured routines, shared responsibilities, and communication with the outside world could be directly adapted to life in floating cities above Venus, where the long distances to Earth may intensify feelings of separation. And let's not forget the International Space Station, our most advanced example of humans living and working off-planet. Orbiting Earth, the ISS operates in a near-perfect vacuum, with no atmosphere, extreme temperatures, and constant exposure to radiation. This environment mirrors some of the dangers of Venus's atmosphere. On the ISS, every drop of water is recycled, every ounce of air is precious, and every piece of equipment is built to withstand the unforgiving conditions of space. From the ISS, we've learned how to maintain complex life support systems, grow food in microgravity, and conduct repairs remotely. These lessons would be invaluable for Venus, where maintaining self-sufficient habitats hundreds of thousands of miles from Earth would demand a similar level of precision and resourcefulness. Even Earth's deserts have lessons to offer. In places like the Atacama Desert in South America, which is one of the driest regions on the planet, scientists have developed innovative ways to collect water from the atmosphere. Techniques like fog nets, which trap moisture from the air, could be adapted to Venus, where water vapor exists in trace amounts at high altitudes. These advancements remind us that even scarce resources can be harnessed with the right technology. What ties all of these examples together is the incredible adaptability of human beings. Whether we're braving the crushing depths of the ocean, enduring the icy extremes of Antarctica, or thriving in the vacuum of space, our ability to innovate has allowed us to survive and even thrive in conditions that seem utterly uninhabitable. Each of these Earth-based experiments underscores a simple but powerful truth. We already know how to create life-supporting bubbles in hostile environments. The floating cities of Venus would take these principles to the next level, scaling up the technology and refining it for a completely alien atmosphere. In many ways, Venus represents the ultimate test of what we've learned from our planet. It challenges us to combine the lessons of underwater habitats, polar stations, and space missions into a unified vision of survival. By building on what we've already accomplished, we can harness our ingenuity to reach new heights, literally. Venus may seem like a world apart, but its challenges are not so unfamiliar. Turning the dream of floating cities on Venus into a reality may sound like science fiction today, but every ambitious venture begins with a sequence of smaller, deliberate steps. To establish a human presence in the skies of Earth's fiery twin, we would need to embark on a carefully planned journey, one that unfolds over decades and combines the efforts of engineers, scientists, policymakers, and explorers. So how do we get there? Let's break down the roadmap to Venus. The first step would undoubtedly revolve around robotic exploration. Before we can even think about human habitation, we need to understand Venus on a much deeper level. While past missions like NASA Magellan and the Soviet Union's Venera program have given us critical insights, there's still so much we don't know about the planet's atmosphere, weather patterns, and surface conditions. Advanced robotic probes would need to be sent to Venus to gather comprehensive data. These probes would include atmospheric drones and high-altitude balloons capable of floating in the upper layers of Venus's atmosphere, where conditions resemble those on Earth. They would analyze the chemical composition of the air, study wind patterns, and monitor the behavior of sulfuric acid clouds to design habitats that can withstand such extremes. Additionally, surface rovers built to endure the crushing pressure and searing temperatures of Venus's terrain could help identify any resources that might support future colonization efforts. Parallel to these robotic missions, we'd need to accelerate developments in materials science and energy systems. The corrosive nature of Venus's atmosphere means that we'd require breakthroughs in acid-resistant materials to even begin constructing prototypes. Similarly, enhanced solar technologies would need to be developed to harness Venus's abundant sunlight efficiently, powering everything from life support systems to propulsion. These technological advancements wouldn't just benefit Venus missions, they could have transformative applications back on Earth as well, pushing forward sustainable energy solutions and new manufacturing techniques. Once we've collected enough data and developed the foundational technologies, the next logical step would be small-scale prototypes. Think of these as the experimental stepping stones to floating cities. Unmanned aerostats, large, balloon-like structures filled with breathable air, could be deployed high in Venus's atmosphere to test long-term stability and resistance to chemical corrosion. These prototypes could also evaluate systems for resource extraction, such as capturing trace amounts of water vapor or processing carbon dioxide into oxygen. By running these tests remotely, we'd gain invaluable insights into how floating habitats might operate under real-world conditions. From there, we could proceed to crewed missions, a critical milestone on the path to colonization. These missions would likely begin with short-term stays aboard smaller, modular floating habitats to test the feasibility of human life in Venus's skies. Much like the early days of the International Space Station, these habitats would serve as laboratories for refining life support systems, recycling technologies, and sustainable agriculture in an alien atmosphere. Astronauts on these missions would also conduct real-time experiments, further refining our understanding of Venus and building the expertise needed for long-term habitation. Finally, as the technology matures and we gain confidence in our ability to live sustainably, the stage would be set for permanent floating settlements. These would be large-scale aerostats capable of housing dozens, perhaps even hundreds of people. Advanced closed-loop systems would make these habitats largely self-sufficient, recycling air, water, and nutrients to minimize reliance on Earth for resupply. At the same time, interplanetary transport systems, possibly leveraging reusable spacecraft similar to the ones being developed by private companies today, would ensure regular communication and trade between Earth and Venus. Of course, the timeline for all of this depends on many factors, including funding, technological breakthroughs, and international collaboration. Robotic missions and atmospheric studies could ramp up within the next decade, while small-scale prototypes might take 20 to 30 years to fully develop and test. Permanent human settlements, though, those could still be 50 to 70 years away, assuming steady progress. But if history has taught us anything, it's that humanity has a remarkable ability to turn the seemingly impossible into reality when we set our sights high. The journey to Venus won't just be about conquering a new frontier. It will be a testament to human resilience, creativity, and our enduring curiosity about the universe. It's not just a vision of where we might live, but a statement about who we are as a species. Explorers, innovators, and dreamers unwilling to be bound by the limits of Earth. The road to Venus begins now, one step at a time, and perhaps one day, floating cities in its skies will remind the cosmos of humanity's ambition and determination. The idea of living in giant floating cities on Venus is more than just a scientific concept. It's a daring testament to human ambition and creativity. Venus, with its extreme contrasts of beauty and hostility, challenges us to think beyond the conventional boundaries of what's possible. It's not just about solving technical puzzles. It's about embracing the unknown and imagining a future that reaches far beyond the surface of our own planet. The planet's unique appeal lies in its surprising similarities to Earth and the tantalizing possibilities offered by its upper atmosphere. The idea of creating a thriving colony in the skies, where conditions are unexpectedly Earth-like, pushes us to reimagine human adaptation in ways we've never done before. Venus represents both a tremendous challenge and an incredible opportunity. It's a proving ground for our ingenuity, resilience, and determination. At the same time, the immense obstacles we'd face on Venus also remind us of humanity's greatest strength. Overcoming issues like toxic clouds, crushing surface conditions, and the sheer complexity of building sustainable floating cities requires a level of innovation and teamwork that could drive breakthroughs both on Venus and right here at home. These same technologies, advanced materials, closed-loop ecosystems, and renewable energy systems may hold the key to solving many of Earth's most pressing challenges, from climate change to resource shortages. And perhaps that's the point. Projects like this aren't just about survival or exploring new frontiers, they're about redefining who we are as a species. Undertaking something as audacious as Venusian colonization forces us to think big, act boldly, and unite around a shared vision of progress. It's about more than just reaching the skies of another planet. It's about proving to ourselves that even the most hostile environments can be faced head-on with creativity, courage, and collaboration. So here's the ultimate question: could humans actually live in giant floating cities on Venus? The answer right now rests in a fascinating middle ground. While the journey remains steep, the possibilities are undeniable. The technologies are within reach, the science is sound, and the human drive to explore continues to push us toward the stars. But this dream also comes with an important caveat. It challenges us to consider where to focus our energy and resources. Should we look outward for new beginnings, or should we first prioritize fixing the problems here on Earth? Or perhaps the answer lies in doing both, leveraging our drive for exploration to improve life on the planet we already call home. What do you think? Are we ready to take this leap into the skies of Venus, or are there more immediate challenges we need to address first? We'd love to hear your thoughts. Share your ideas in the comments below. And if you enjoyed this journey into the future of technology and humanity, don't forget to give us a like and subscribe for more thought-provoking explorations of what's possible. The universe is vast and there are countless stories waiting to be told. This is just one of them. Let's keep imagining together.